In this video, I'm going to do some practice exercises using the gauge surface plate accessories, V-blocks, 1, 2, 3 blocks, the gauge pins, feeler gauges, and the jacks. We'll go through a few exercises. You can find these exercises on the Pragmatic Metrology website. You'll find a PDF where you can download and follow along. You'll also need the angle block drawing and the step shaft drawing, as well as if you have a part with an inner diameter for measuring run out on a pin. That's going to be one of our exercises. So since I don't have an ID feature on the step shaft, I've got this small part with a through hole on it that we're going to use instead. So feel free to download the drawings from Pragmatic Metrology website. You'll also find CAD models if you want to 3D print these or machine them yourself. And if you don't want to, just grab your own parts that have similar features and just substitute with what I'm using. So let's look through our exercise. We're going to be using both those parts, all of these gauges here. We have our drawings that we can reference. And well, let's just get started. So we're going to practice using the accessory gauges with the surface plate. First one we're going to do is we're going to practice using the gauge blocks as a go no-go gauge for the slot on the angle block. So it says to ring blocks together, inspect the width of PM-02, slot nominal 405. Find the tightest fit down to 1/1000th of an inch and verify your stacks. So let's take a look at our drawing. Let's flip. Oh, here it is. So we have a through hole of 0.405 and the title block tolerance is plus or minus 5 thousandths. So that would be 0.4 to 0.410. So we do have a 0.4 block in our set. So I'm going to try that one first. And I'm going to verify as I mentioned once before, the 400 looks pretty symmetric. So this is the 400 size. And we'll run that through. Alright, so my go size goes easily all the way through. Let's get a 410 stack. So to get a 410, I'm going to use a 110 and a 300. And I'm going to verify, there's my 300. And we're going to do our assembly process, cross them, twist them, slide them. And let's verify this stack with a micrometer. So it should be reading 410. And there we are, we're reading 410, just a hair above, but this micrometer is reading a little bit large. So we have a good stack here. Let's see if our 410 goes in. Really doesn't want to start. I can just kind of force a corner in, but really can't get it to go. So now I'm going to replace the 110. There we go. I'm going to replace the 110 block with a 105 and see if that one fits. So we're trying to find the largest pin the largest gauge that will fit. We've already verified the slot is within tolerance. The 400 did go, and the 410 did not go. Let's try the 405. So the 405 is going through the beginning and then it stops. So it stops on that side. Try to show this on the camera. So it stops right there. That means there must be some sort of pinch point, maybe some deformation due to machining. So let's keep going down. Let's find the one that goes all the way through. So I'm going to try the 103 and the 300. So make a 403 stack. Let me do this on camera. Twist, slide, and we go through. So I skipped the 404 size. Let's see if that one goes. Alright, so gotta clean these off a little bit. Twist, slide. And it's pretty tight, but it goes. So that would be 0.404 would be the largest side that goes all the way through. And that means it's within tolerance according to our drawing, and it's a great way to check slots. So I really like checking what's tight tolerance. It's a great tool to use, the gauge blocks. And for open tolerance, yeah, in reality I might have just used a caliper on both ends, 404, 408. So it definitely is a little tapered or something's going on, but both sides are in tolerance. But I still like using Joe blocks for that reason. Number 2A, using Joe blocks, perform a transfer measurement on PM-02 distances 3.210 and 3.450 using the test indicator, and then repeat with the scribe. So let's take a look at those distances. 3.210 is so 3.210 is the distance from this back side to the first step, and then the next one will be to the next step. So I've got the print right here. You can follow along. So I need to build a stack that is 3.210 large. So I need to get, basically a 210 stack and then add a 3-inch block. So I'm going to use the 110 and the 0.1, and let's cross those two together, stack them, and then build the 3. Now I don't have a micrometer this large to verify my stack, so I'm going to use a caliper just to give myself a sanity check. 209, and in reality this caliper is probably 1,000th off. So let me double check I grabbed the right. I got the 110 and the 0.1. So I grabbed the right blocks and my caliper reading is just a little bit off. I'm not too concerned about that. I have confidence in the stacking of these blocks. So, but if I grab the block that was 10 thousandths off or 100 thousandths off, you'd definitely see it with a caliper. So that's why I do that quick sanity check. So setting this up, giving it a quick slide, make sure it's seated correctly. I'll bring up our gauge. And I've already got my indicator at a good angle to avoid cosine error, so remember that. And I'm going to bring in some pressure and go to 0. Alright, I'm on 0. I don't need to worry about the dial on the height gauge or the counter because I'm not using that at all. I'm only using the indicator. And from the 3.210, I've gone plus 1, 2, 3 thousandths. And I slide along and check the whole surface. And right now, because I have a plus or minus 5 tolerance, really all I'm looking for is that this indicator stays within plus 5 and minus 5. And that way I'm in print. So I'm staying under the 5 at all times, even though there's a little movement. There's a little step on this part in one area, but it all looks pretty good. Let's build up the next stack. The next stack is 3.450. So how am I going to get to 450? Well, actually, I've already got a 450 block. So I'll take my 3 and my 450, and I got a little oil on my 450, so cross it, twist it, slide it. There we go. Drop it down here. And just gonna repeat it. Bring in my 0. All right, I'm a little bit plus, but I'm under the 5,000 title block requirement, sweeping the whole surface. Now you can choose to either sweep the height gauge like I'm doing, or you can sweep the part. It makes no difference. It really just a matter of preference and which one's heavier, which one can you control better. I typically slide the part, but actually I'm starting to I like the size and weight of this height gauge. It's easy to move around as well, so feel free to choose either method. So we're in print, and now we wanted to repeat this with a scribe, and let's see what that process is like. So I'm going to switch out my indicator and toss on my scribe. Now I no longer have an indicator, so when I go to zero this, I actually will need to zero the counter and the dial. So let's try to get that in camera. Do it over here. Okay, so I'm applying a little bit of pressure, stops, very light touch when you're coming down and registering that scribe. You don't want to over travel it. At zero. So now I can lift it up, slide my block out, slide my part under the step, bring it back in, and I think you can see it on the main camera a tiny bit, but on the secondary camera you can see it's about plus 0.003 from where I zeroed it on the gauge block, and that's consistent with what we saw with the indicator. And slide the part and check the other side. It's about 2.5 plus, maybe 2, closer to 2 than 2.5. So again, both methods, choose which one you like, whether you like working with the scribe or like working with the indicator. They both have some value for different situations. When you are using the scribe, I want to emphasize, bring a very light touch. Just grab the outside of the wheel and bring it down very gently, and then when it stops, your fingers will kind of roll off. If you keep applying a lot of pressure, you'll jack up the height gauge, or you'll deform the part, twist the part. Something will go out of balance. So you need to be very, very light. With the indicator, it's not as drastic because the indicator will usually move before the height gauge moves or the part moves. It'll just change whatever angle you've put the the natural state angle, for lack of a better word right now. So this will start to actually change its resting angle when you start to go down with too much pressure, but you'll actually jack up the height gauge, and it's just like any other tool. You got to give it a light pressure and practice your pressure. Okay, so we've basically done both methods, and let's flip back to our instructions. So we've done 2A, repeat with the scribe. 2B, repeat measurement without using Joe blocks, by using height gauge with a dial indicator, and again with the scribe. So basically, just to hammer it home, all the different methods you can do. I'm going to put away our height gauge, or our Joe blocks, and I've already got the scribe loaded, and we're going to repeat the same process without the Joe blocks and without zeroing on them. Just use the scribe for now. So I'm going to bring this down and I'm going to zero. Okay. Bring this up. And now we're going to be using the counter, and we're going to be using the dial. So I read 3.212. Again, pretty consistent with what the other methods we used. and 3.2, 12 again. And I can go up to the next one and read 3.452, and the other one I can read 3.452 again. So of course you have both, should be consistent no matter what tool you're using. And what it comes down to is technique. Which technique are you better with? And accuracy. What level of accuracy do you need? So with a dial indicator, sorry, a test indicator, I'm going to zero everything again. Get the counter, get the dial, get the indicator. Right. And we'll come up. And now I've got to bring the pressure until the dial reads 0 again. Wow, I'm getting really good at this. And we'll take our reading 3.213. And actually I didn't need to lift it, but let's see if I get lucky again. Getting pretty good with this indicator. Again, 3.213, and I can slide it around. There's a little bit of movement, especially with the chatter on the end, but otherwise pretty stable. We'll go up to the next one. And let's see, 3.453, and it's pretty flat and parallel. A little chatter on this step right here. So I've now demonstrated the scribe and the indicator using Joe blocks and not. Think about what were the differences. There were a few differences in numbers. I can't deny that. With this open tolerance, every method I used was within print. So that, when it's open tolerance, you can choose any method that you're comfortable with and you think is quickest and easiest and accurate, of course. When it's tighter tolerance, I really want to emphasize bringing the Joe blocks into play and using a test indicator, because you are going to really get to see, amplify what's going on when you're using the test indicator, and you're going to bring in the accuracy of the Joe blocks without involving the height gauge accuracy. So the differences in all these different techniques that I had and different numbers, sometimes you're using the height gauge travel, sometimes you're not. Sometimes you're using the indicator, sometimes you're using the scribe. There's a lot of, additions and subtractions of accuracy. But I would say, if you're working on something tight tolerance with maybe 1,000, 2,000 tolerance zone overall, 0 on the gauge blocks and do a transfer measurement, which was the first thing we did. That will give you not only an accurate reading, but it'll actually very easily show you what's going on, because you'll be able to drag your indicator across the part, look at the entire thing, and compare it to your reference stack. And if you set your reference stack at nominal, again, it allows you to do an easy, plus or minus visual on the guide, on the gauge. You'll be able to see very easily, are you within tolerance or not, just by visually looking at your tolerance zone and seeing where the indicator goes. So I really like that method. So let's move on to number 3. So we're going to start using pins with the angle block. So measure the location of 2 holes on PM-02 angle block using combination of the following 3 methods. So let's pick our holes. Well, I'm only going to do 1 hole just to save a little bit of time. I'll do the 375 plus 5. Actually, I only have pins for 1 of the holes, so why don't I verify yeah, we'll do the, so we're gonna, oh, you can't see. We're gonna do the 375 hole, plus 5/10 minus nothing on the PM02 drawing, which is right here, this call out. So we're gonna do the position of that hole. Oops, a little too far. So let's do 3A. Insert pins into the hole. Find the distance from the rock to the top of the pin using a height gauge and shot math with the radius of the pin. Use both the test indicator and the scribe attachment. So let's do the test indicator first. So I've inserted the largest pin that will fit in there, which is a 0.3785. Okay, I've got 0 there. Now we're going to bring up to sweep the top of the pin. So we need to find the top of the pin before we can do any measurements. So I'm looking for that inflection point where the needle changes direction, which is right here. So I know this is the high point, and then I'm going to bring in my pressure to 0. And we're going to look at how much we traveled. And I'm going to be writing this down so we can do our math. So it moved, let's see, 0.688. So I have 0.688, and my pin size, what's my pin size? My pin size is a 0.3875, so I need to divide that by 2, 3,785. So I've got 150 plus 35 is 185.189, and maybe 3/10 or 2/10. So as a quick cheat, here are my notes. I've traveled 0.688. My pin size radius is 0.189. So we're gonna, since I went above the center point of the hole by the radius, I'm gonna subtract that to get to the center point. So we'll do 0.688 minus 0.189, 7, 18, 9, 5, 17. 17 minus 8 would be 9. Sorry about that. And 5 minus 1 is 4. So our center point is 0.499. Sorry about that. 499 from the rock. I did round a little bit because I don't have a calculator with me, but don't round off until the very end when you're done. So when I divide this pin, I divided this pin in 2 and rounded off a little bit for the math, but 0.499 makes sense because our print requirement is right here, 0.5. So let's double check. I'm still on 0. Maybe it's a little off. There we go. Still on 0. And it's a good idea to check both sides of the hole because the hole might be at a bad angle. And you know what? It is. So I don't know if you can see, but the indicator's moved off 0 about plus 2 thousandths. So that means I need to adjust my pressure. And my new reading would be 0.690. And if you do the math again, you go through all this math, replace 0.690, you end up 2 thousandths higher, right? You added 2 thousandths to this one, so you end up at 0.501. So that means this hole is slanted upwards just by about 2 thousandths from end to end. But both ends are in tolerance. We have 0.500. We will, for the sake of this exercise, we'll ignore the true position requirement. We'll just treat it like title block, but just to make things easier. So we'll just treat it like title block for now. I'm going to do a true position video where I explain how that tolerance zone is affected by the true position requirement. But both ends are in print, whether it's 499 or 501. So let's do it again with the scribe. Let's see how the scribe affects it. So I'm going to zero on the rock. Make sure to avoid parallax there by getting a good, nice look at directly on. Alright, I'll try to give you the best angle I can. Alright, so what are we reading? I am reading 0.689. So we end up just plugging into the same formula with the scribe, and 0.689 translates to 0.500. So we've got pretty consistent readings, although not exactly the same. And you know, that is kind of due to the nature of different things being involved, whether it's an indicator or a scribe, but it should be relatively the same, or ideally exactly the same. Once again, I think using the indicator is going to be the most accurate way to do it. The indicator and the pin is going to increase your accuracy. Your pin is, you know, a very smooth surface, and it's registered with the center point of the hole. So, and the indicator kind of amplifies what you can see. So that's why I like to do it. Now I want to take a quick moment to make a take a little detour, and I want to show you something when working with a height gauge. So I don't know if I'll try to get this on camera. Right now, when I'm looking at the counter and the dial, visually I can see a 0.7 very clearly, and my dial is saying 89. So I told you it was 0.689, 0.688. But why is my height gauge showing 0.7? Why didn't I say it was 0.788? This goes into our discussions on micrometers and calipers when you're dealing with vernier scale. This is the same thing. These counters are not perfect, and because I can see the 7 so clearly, I know I'm close to the 7, 0.7 I should say. So it wouldn't make sense for me to say 0.789. That's very far from the 7. If that were true, I would be seeing a lot of the 8. The way these counters work, as you travel around, you can kind of sometimes see halfway in between an 8 and a 9, for example. So it's just like when we're doing our vernier scale, when we're reading our micrometers, and we're trying to see how close we are to 0, counting lines. It's the same concept. So if I put this back at 688, I can actually see the 7, but I know I'm not there yet because I haven't reached 0 yet. So even though I can see a lot of the 7, I'm just not quite there yet. And this is one thing that confuses people when they're using the counter style and they're not using digital style. They're not used to the counter style and the sort of quirks of developing a counter system where you have to add numbers together and look. So keep that in mind, and always remember, if you're confused, and you can grab a caliper and try to verify it, you'll see whether you're 100 thousandths off because you read the indicator wrong. And again, another good way to do that is practice. Build up a stack that you know is 0.688 from the Joe block stack here. Bring that into focus. From the Joe blocks here, build up a stack that you know is 688, and then take a look at what it looks like on the dial. If you're using a counter height gauge for the first time, that can be an important step. So I wanted to point that out. Okay, I think we've done half of that hole. Let's take a look at our question, our exercise here. Use both test indicator and height gauge attachment. So we've completed 3A, except for the fact that you would want to rotate it 90 degrees and do it the other way. Save a little bit of time. I am going to continue. But it's the same process. It's exactly the same process. You just rotate it and go from the bottom to the pin. So 3B, repeat 3A by measuring from the top of the part to the pin and using the part overall height. So what's this saying to do? This print is set up with the datum on the bottom surface, and it's a finished part. So it makes sense to put the datum on the surface plate and work from the bottom up to the pin. But in your careers, you may run into a situation where you can't do that. You can't go the direct method, or it may be that the surface, that the datum is the top surface, and you just can't put that top surface on a surface plate for some reason. You're going to have to go the other direction. So I want to show you how to handle that situation, just so you see it. I've already got our scribe loaded. So, because one day you may need to do this, we'll zero off the top. I'm zeroing the counter. Okay. Try and get you where you can see it. We'll go down to the pin. So I am reading, oh, you know what? Our counter is going backwards, so I'm going to go up just to save myself, because I don't work with counters all the time either. You know, I gave you that warning about misusing them. Oh, dang. I'm going to work my way up from the top of the pin. It doesn't make a big difference. So I'm going to zero on the top of the pin and then work my way up, because when you work your way down with a height gauge, it starts counting backwards. And this one is counting backwards from 100. So that's an extra step of math I don't want to deal with. Alright, so I'm going to count up. So from the top of the pin, 1.663. I'm doing a little bit of rounding just for some math, make math easier. 1.663. So that was our distance traveled. We have our radius from the previous calculation. So to get to the center point from the top surface, I'm going to add the radius this time, because I want to know where the center point is relative to the top. So I'm going to add 189. Sorry for my left hand blocking the screen, but it's unavoidable. 12, 14, 15, 8, 1.852. So it's 1.852 from the top surface to the center point of the pin. And now, you know, this could be a situation where the bottom is still like unfinished. It might be flat, but there may be extra material. But you want to give yourself a check to say, all right, did he put it drastically off so that when he finishes the part, is it going to be in print? That's one of those in-process checks you may need to do. The machining operations can be in any order. Surfaces can be finished in any order. So you may need to do something like this in that situation. So I'm going to grab the overall length with the caliper. Certainly could do it with the height gauge, but save a little time. 2.348. Okay, so with overall height, I forgot the number already. 2.348. Okay, so we'll do our math. This number minus this number. And we should get the center point from the bottom. Doing that math. 6, 9, 0.496. So not the same as our 0.499 or our 500 that we had before, our 501. And as I mentioned before, when we put the pin in, it's slanted in one direction, but overall, this number is still in print. This 496 is still in print, and just a different way of doing it. I would prefer the direct method. Just want you to practice using the indirect method. We can practice again using our indicator. And with our indicator, we'll kind of go through the same process. So I'm going to 0 on the top surface. And just going to check the whole thing. Yeah, there's a little bit of difference, so got to keep that in mind. It's not too bad. So, and you know what? I forgot. I would prefer to 0 on the pin and then go up. For this height gauge. Not every height gauge will count backwards from 100, but this one does. And I've already made enough math mistakes on video. Minimize my chances. All right, 0. Let's see what we get using the indicator. All right, 0'd on the indicator. Now there's 0. So what am I reading? 1.662. Which is a 1,000th difference than my scribe. So it's going to end up at 497 when you do the math all said and done using the radius of the pin. So again, bunch of different methods. Don't always achieve the same result. That's unfortunate, but that's the reality. Stick with the most accurate methods when you really need that accuracy, and it's okay to use some of the other ones when you have more open tolerance. Generally speaking, clearance holes are open tolerance. This one's got a true position requirement, which we're going to practice true position in another video. So, but just take a look at your position tolerances and your size tolerance when you're deciding which approach you're going to take. All right. 3C optional. Repeat using the drop gauge. What else would you need? Of course, you're probably going to need some Joe blocks or 1, 2, 3 blocks and shot math, because when you involve the drop gauge, you're going to involve zeroing either on the surface plate or on a Joe block. If you have to travel a large distance, say this large distance, we're going to need to involve a Joe block. So why don't I demonstrate that just one time. We won't go through the multitude of exercises, but let's demonstrate that. Alright, I think you can see the indicator relatively well. It's not bad at all. Alright, so there's no way I'm going to be able to lower the indicator and still reach the top of my pin. It's just not enough travel. So what are we going to do? I'm going to look at my nominal. My nominal is 2.5 inches, and I'm going to be using the pin. So I feel like using a 2-inch Joe block will help me set our zero and maintain the range of the indicator. So I'm going to do a quick range check. I can zero off of that, and oh, I need to raise it a little bit more. I can't get to the top of the pin. So I'm going to zero off of that, and then I'm going to check it on the pin. So let's do that exercise. Got my 2-inch block. Zero there. And then just to make things easier, let's count. So 0, 1, 2, 3, 4, 5, 6, 7. I think I'm above. I am above. So now I end up, I'm going to try to get as close as I can to the sidewall. Okay, you can still see. As close as I can to the sidewall. And take my reading. I went around 6 times. I almost got to 7. So I'm at point 689. That sounds familiar, right? So let's do our math again. Get a new piece of paper. So our travel from our indicator was 0.689, and we offset it by 2 inches. So I start off with 2.689. I need to add the radius of the pin. Actually, do I need to add it or subtract it? I went above it. I need to go back down. So I need to subtract 0.189. And my final distance, exactly 2.5. So it's a pretty handy way to do it, honestly. Like I said, I mentioned before, I really like using drop indicators when I can. They're very stable. They don't mess around. They just move up and down. You don't have to, what you have to worry about is you have good anvil contact in the center, but because the anvil's so big, it's pretty easy to get on the center. And then lifting it up, the gauge block isn't adding any error to this. We know gauge blocks are very accurate, so pretty nice way to do it when you can. One thing I'll point out for one thing, I mentioned that when we had the block in this orientation sitting on the rock, we knew it was slanted up and down this direction, or it might have been the other direction. When you rotate it this way, you still need to double check that. So let me check both sides. and I get point as close as I can, about 0.689. Flip it around, 0.689. So with it oriented now, the way it's pretty straight up and down, because we're not seeing any movement between the two sides. One thing I want to point out is I mentioned I'm getting as close as I can to the part, and one thing that sometimes happens is you extend your pin out very far from the part. I'm now reading 0.687 instead of 0.689, and the difference is that whatever if we pretend this is the surface plate here, resting on our surface plate here, whatever out of perpendicularity error exists, the farther your pin extends, away from the part, well, that perpendicular error gets amplified, and you'll pick it up more and more. So it's good to get as close as you can to the body of the part so you're not getting any false readings of amplified error. And that's true whether you're using an indicator, a test indicator. If you're running your test indicator far away from the part, that error is also going to amplify, or a scribe, or anything, even any other tool. But it's really noticeable with indicators. So as much as you can, register your contact close to the part and avoid that issue. All right, I think we've completed step number 3. Let's take a look, and then if we have, we're gonna stop this video, pause for a moment, and then keep going. I think we've accomplished it. Another way you could have done step number 3, I would say, you don't have to necessarily start from below the pin. I have my gauge block below the pin. You could start from above the pin and go down, and then all that's different is the shop math becomes different. It becomes a little more complicated that way in this setup. So I like to go up. It's a little easier. The math was very easy, as you saw. So, but you have options. Keep these in mind. Every situation is going to be different. I could have used the top of the part and dropped down to the pin, and then use the overall length of the part. Right? So we have a lot of options that way. But I want to thank you guys for watching. I'm going to take a quick break and continue with exercise number 4. All right. Thanks.